What's up, boys and girls? It's me, your boy, your math teacher, Mr. Barton. Today we're going to talk about properties of exponents. And you might be noticing that things sound a little quieter. Listen. Do you hear how not staticky that is? You don't hear like the fly buzzing around my head and the like sound. You know what I mean? The breathing sound. Um, Someone showed me where noise cancellation was on my recording software. So hopefully, things are a little bit more easy on the ears. But let me know. I hope it's better. So today we're going to talk about properties of exponents. There are three specific properties we need to talk about. We need to talk about what happens when we multiply, what happens when we divide, and what happens when we have something to the power of 0. These are the three properties we're going to worry about today. There are a few more, but that's someone else's problem. Probably my problem in a future video, but you know what I mean. That's future me's problem. Don't trip about it yet. So let's go talk about some things. Okay. The first thing I need you to understand is the vocabulary of all the words that is coming out of my mouth. Okay. First of all, the big number sitting in front of a term, that's called a coefficient. You've probably heard me say that like 1,000 times. And if you don't know what that is, I bet you can still hear my dog walking through the doggy door, can't you? Anyway, I hope you remember what a coefficient is. Okay. Obviously, 3 is called an exponent. It's the little tiny number that's raised up. These are actually superscripts. Super meaning like big or up. Script as in like a written thing. Oh my gosh, if my dog goes outside one more time, I'm gonna clock him. I'm gonna suplex that boy right to the moon. I swear to God. I swear. He is driving me absolutely nuts. But don't worry. He won't be a problem anymore. All right. The little thing that the exponent is on, and this here is an x. It could be a number. It doesn't have to be a variable. The general name for the thing the exponent is on is a base. And we're going to need to know that word for eons to come. It comes up in several other lessons, so make sure you file that somewhere you're not going to lose it in your brain compartment. Then if you see a number just hanging out by its lonesome, no variables, no exponents, we call those constants. All right. Now that you know how to talk about stuff, let's go learn some properties of exponents. So the first one we want to know is the power rule. So let me explain the rule to you, show you why it works, and then we'll do some practice with it. This is a rule I've mentioned multiple times before, particularly when we're multiplying stuff together. It's something that I feel like maybe we should have talked about a while ago, but for some reason it's not scheduled till Unit 3. But c'est la vie, I just teach you this stuff. I don't write the schedule. So what the power rule says is if we have a variable to some power times a matching variable, meaning the bases have to match. So x to the third times y to the third, this does not apply to, right? It has to be x and x. So if we have two bases being multiplied together and they have exponents, we can simplify this by putting one base, the base that they have in common, and then adding the two exponents together. So if we look at this example here, n and n, so the bases match, and they're being multiplied together. So what we're going to do is add their exponents. So 5 plus 2 is 7, so we can simplify this as n to the 7th power. Let me go ahead and try and show you why this happens. So n to the 5th power is the same thing as n times n times n times n 5 times. That's that right there. And then n squared is the same thing as n times n. All right. if I have this list of n's being multiplied together and these two n's being multiplied together, what do the parentheses tell me to do? That's right. They are telling me to multiply together. So what I have written here is the same thing as this. And now this is just 7 n's being multiplied together. So it kind of makes sense why we're adding the exponents together, right? We're just putting 2 more n's in that list that we're multiplying, and then we're good to go. All right, so when we multiply, we add the exponents. So let's look at some like big kid examples so that you don't accuse me of just teaching you the easy baby stuff. So when we are multiplying these two terms together, the first thing to note is that there is no adding or subtracting sign in here. This is just multiplying. So what we're going to do with our coefficients, the -3 and the 9, we're going to multiply those like regular. So -3 times 8, sorry, did I say 9 the first time? The 8. -3 times 8 is -24. We don't need the power rule for that. We can just do multiplying. What we do need the power rule for are the exponents on these variables. So we have x to the 4th here, and then we have an x here. If you don't have an exponent, the invisible exponent is a 1. Same thing with this y here. So x to the 4th times x, we're going to add the x's exponents because they're matching bases. So 4 plus 1 will be 5, and we have x to the 5th power. Y, we have 1 plus 7, so we'll have y to the 8th power. And then z has 2 and 9, so we'll have z to the 11th power. All right. If we look at this next example, we don't have a coefficient in front of these terms inside, but we do have a negative. This is like a -1. So we're going to do -1 times 3 is -3 for our coefficient. Then we just look at the exponents on the variables and add them together if the variables match. So put our 1s where they're invisible. 2x's times x to the 1st, 2 plus 1 is 3, so we have x cubed. Y to the 1st power times y to the 10th power, 1 plus 10 is 11. And now there's not a z out here for me to add exponents with this z, so we're going to just bring that down, because if there's nothing to add to it, it just stays the same. So z to the 3rd power. And then this is our answer. Pretty easy. All right. Let's talk about the power of powers rule. So I really wish we were in person right now. I have this really dumb dance that goes with this. And there's no way that I can possibly show you the dumb dance right now because you can't see me, right? But if I get to 100 subs, we're going to do a face reveal, and then you'll get to know what I look like. So for the power of a power rule, we have some base. In this case, it's a. Before it was x or y. It doesn't really matter. A is just any base to a power. And then that whole thing is to a power. What we're going to do here is multiply. We're going to distribute the outside power into the inside powers. Let me try and explain to you why that is. Let's say we have x squared to the 3rd power. What this means is x squared times x squared times x squared. So we have 3 2's being added together. So we're multiplying, right? 3 times 2 would be x to the 6th. So if we expand this out, it's pretty easy to see how the power rule works. So let's look at some baby examples real quick. We have f to the 4th power to the 6th power. We're going to distribute the 6 into the 4. 4 times 6 is 24, so we're going to have f to the 24th power. Here, we're going to distribute the 2 into the exponents here. This 7 has an invisible exponent of 1, so we're going to distribute the 2 to both of the exponents. So 2 times 1 is 2, so we're going to have 7 to the 2nd power. And then 5 times 2 is 10, we'll have a to the 10th power. Now, there's a rule and this is more like a class rule and just like being a good human being rule. Don't leave powers on numbers. You can do 7 times 7. So let's simplify 7 squared. This is 49. Bring down your a to the 10th power. And then that's your answer. So if you have a number with an exponent on it, you need to simplify that. All right, let's look at some big kid problems. So here we have a 3 outside the parentheses. So that tells us we're going to distribute the 3 onto all the exponents, including the 1 on the -3 and the 1 on the y. So we're going to distribute. So we're going to have -3 to the 3rd power. And I'll explain why I'm putting this in parentheses in a moment. 3 times 4 is going to give us x to the 12th power. 3 times 1 gives us y to the 3rd. And 3 times -2 gives us z to the -6. Now, we need to do -3 to the 3rd power. So that's -3 times -3 times -3. 3 times 3 times 3 is 27. A negative times a negative is a positive, times another negative turns it back negative. The reason we're doing that, these parentheses here, is because if you put exactly -3 to the 3rd power, just like you see it there into your calculator, it'll tell you it's -27 like it should. But if this were a 4, this will give us -81 when that's not true. What we want is 81. So anytime you have a negative on your coefficient, you need to put it in these parentheses because there's certain cases where your calculator, if you're using one of those to simplify, will give you the wrong sign answer because it does order of operation probably better than most of us. So we need to make sure we put our coefficients in parentheses, especially if they're negative. Then just bring down all of your variables with their exponents. All right. Let's look at this other example. I'm going to be quite frank with you. I don't 100% understand why this is in this weird power section, but we can do it just for practice. It's not going to kill us. Unless it does. That would be pretty awful, right? What if you came home and your mom saw you just dead on the keyboard, drooling? She runs over to you, "Mijo, wake up, mijo, please. I'm too young to be a..." What do you call moms who have lost a son? I don't know, but you know what? You get the idea. Your mom's too young to bury her favorite child. So we're going to go ahead and just FOIL this. This is foiling. We'll use some of the stuff we learned, but, you know. So we have 3x times 2x. So 3 times 2 is 6. X times x. Aha, now we can understand why it becomes x squared. Because these both have powers of 1. So we're multiplying. We add their exponents and get x squared. It all makes sense now. All right. 3x times 1. 3 times 1 is 3. Bring down your x. -5 times 2x. -5 times 2 is -10. Bring down your x. And -5 times 1 is -5. Combine like terms in the middle. We have 6x squared minus 7x minus 5. All right. And hopefully after unit 2, you have this like insatiable desire to try and factor this now. That's a good fire to have in your belly, but, you know, rein it in a little bit. You don't need to factor. It's asking us to multiply. I know what it factors to. Factors to that. That's already the answer, duh. All right, let's go look at some more problems. Aha. The elusive negative exponent rule. All right. This one can be a little bit challenging for students. If we have a negative exponent, the way we make that exponent positive, we don't want to leave it as a negative. But Mr. Barton, you just left this one as a negative. Yeah, I know. It's because it's one slide too early and I haven't taught you the rule yet. Now I'm teaching you the rule. The rule is take the base and the exponent, move it to the other side of the fraction, and make the exponent positive. So this would go onto the bottom, become a to the power of m, And because the top is then empty, we would just replace it with a 1. All right. Same thing goes if it's on the bottom. We would move it to the other side of the fraction, so to the top. It's multiplying to the 1, but 1 times anything is just the anything. So a to the m. And then it would be over 1 because we leave the bottom empty, but dividing by 1 does the same thing as multiplying by 1, which is absolutely nothing. So it simplifies to a to the m. Okay. Let's look at the baby examples, and then we'll go do some big kid examples that'll put hair on your butts, and then off to the races with you, and you're going to do some homework. So x to the negative 5th power. We put it into a fraction. We take the base and the exponent, move it to the other side of the fraction, and make it positive. So we have 1 over x to the 5th. On this one, we take x to the negative 7th. We move it to the other side of the fraction, and then we make the exponent positive, and then it would be over 1, but who cares? So x to the 7th. All right. Now, okay, we've got to learn one more rule. We'll do one more baby example. Then we'll put it all together and do big kid problems. If we have a rule for multiplying, let's think back. A to the power of m times a to the power of n. What do we do with those exponents? When we multiplied, we added the exponents together. So what do you think you should do if you were dividing? Subtract. That's very good, children. You're so bright. Oh my goodness, your mother must be so proud. So you're going to subtract. The rule is always top minus bottom. Okay? So if we have a to some power m divided by the matching base a to some power n, it will be m minus n. Notice that the bottom is the thing with the negative sign in front of it. That's super important. Okay, so if we want to do this example, x to the 5th divided by x to the 3rd, this is going to be x to the top minus the bottom. 5 minus 3 is 2. Okay, the way I initially thought of this when I was learning it is I thought of this as x times x times x 5 times divided by x times x times x 3 times. And when you divide something by itself, it cancels out and goes away. So this x cancels this x. This x cancels this x. And this one cancels this one. And then we can see we have 1, 2 left over. So x to the 1st times x to the 1st is x squared. So you're really canceling top and bottom. And then whichever one has more, that's where your answer is going to go. All right, let's look at these examples. And then I think I might have lied. There might be one more rule, the one with the exponents, the special exponent. But let's do these first. So, all right. For your coefficients, you just reduce those like you do normal coefficients. So 5 over 20, 5 goes into both of those. 5 goes into 5 1 time. 5 goes into 20 4 times. Now we're dividing variables. This x has an invisible 1, so it's going to be 7 minus 1 is 6. We'll put it on top. Now we have 3 minus 7. That's negative 4. So we're going to have y to the negative 4th power, and we'll fix that in a second. And then the z has a 1. 1 minus 2 is negative 1. So we have z to the negative 1 power. Now, I just told you you can't have negative exponents here or here. So we need to move the y and its exponent to the other side of the fraction and make the exponent positive. And the same thing with the z. So our final answer is going to be, as soon as I move this out of the way, 1 over 4, x to the 6th, y to the 4th on the bottom, z to the power of 1, but I don't write 1s on the bottom. You could get rid of this 1 if you wanted. You could just put x to the 6th over 4, y to the 4th, z. That's probably the cleanest way to write it. And that's your answer. You're done. Another way that you could maybe skip this step is you could think about it like this canceling process that I showed you here. 3 of these will cancel 3 of these. So 7, take 3 away would be 4. And the 4 would be on the bottom because there's more on the bottom than on the top, right? So you can kind of skip this step if you're really careful about it. But if you're not a careful person and you think math is whack and you're like, you can't make me do math. I'm an independent teenager and I have opinions and you can't make me do anything. Then feel free to miss the problem. I don't care. But if you're a careless teenager and you have thoughts like that deep down in your heart, maybe you should do it the long way because you realize your teacher's trying to help you and not just make you unhappy. All right, let's go ahead and do this problem. The first thing we want to do, actually we have options. We do have options. And because I'm here and you can't tell me your opinion, I get to do whatever I want. So I think I might show you how to do it both ways. Okay, the first way is we could just go ahead and distribute this 2 exponent to all the exponents, top and bottom. Okay, so we're going to have negative 20 squared x to the 4th, y to the 30th, over 2 squared x to the 10th, y to the 18th. Now we should clean up these coefficients. Negative 20 times negative 20 is going to give us positive 400. 2 squared is 4. Now, if we look at our x's, these 4 on top will cancel 4 on the bottom. 10, take 4 of them away would be 6. So we'll have x to the 6th on the bottom. With our y's, we have 30 on top, we have 18 on the bottom. So these 18 will cancel 18 of these, and 30 take away 18 is 12. So we'll have y to the 12th on top. And then we should just reduce these coefficients here. 4 goes into 400 100 times. So our answer is going to be 100 y to the 12th over x to the 6th. That's the first method. We can distribute the 2 in and then simplify everything. But we do have options. Math is not a very strict, well, it is strict. It requires perfection, but it's not as strict as some of you think it is. We could do this in a different order. If we think about order of operation, PEMDAS, then you're going to notice parentheses comes before exponents. So if we want, we could simplify the inside of these parentheses, then distribute the exponent. And we could try it that way. So let's try it that way. I'm going to go ahead and delete this stuff, except for the answer. I want to keep the answer so that we can compare and just prove to ourselves that, it works and our teacher's not lying to us like he did the other day. So negative 20 divided by 2 is negative 10. I had 5 x's on the bottom and 2 on the top. So these 2 cancel 2 of these. We have x to the 3rd power on the bottom. For our y's, 15 minus 9 is 6. So we have y to the 6th up there. We still have this 2 outside. So now we're going to distribute our 2 onto everything, including the 10s, the 6, and the 3. So negative 10 squared, negative 10 times negative 10 is 100. 2 times 6 is 12. And then 2 times 3 is 6. And lo and behold, these match. They're the same. Oh my goodness, it's almost like math is self-consistent. It's so beautiful. So you have options. You can either simplify the inside first and then distribute the exponent, or if you like big numbers, you can distribute the exponent and then simplify. Both will work just fine. It's whatever you want to do. All right, let's talk about the zero exponent rule, and then I believe you are done and on your merry way. So there is a rule. The rule goes anything, no cap. I learned that from my my second hour. No cap. Anything with a 0 exponent, always 100% of the time equals 1. So this thing, regardless of what it is, to the power of 0 equals 1. Check mark. So let's look at some examples. X to the third, y to the 7th, z to the 8th, all to the power of 0. You don't even need to think about it. Everything inside here to the power of 0 equals 1. You're done. That's the problem. Every year I have kids miss this on the test. And then it's always one like this too. So they do all the hard work. They simplify the inside. They simplify to the power of 0. And then they say it equals 0. Wrong. All of this stuff doesn't matter. You don't need to reduce this to 3 over 5 x squared y to the 8th z to the 8th. You don't need to do any of that. All you have to do is see the 0 on the outside and say that equals 1. Here, let's even make up a really hard problem. And I want you to show your mother or whoever you live with. If you don't live with your mom, show your dad or your aunt or your uncle or your grandpa or your group home owner, leader, liaison person. Show them this problem. Write this down. Parentheses. The integral from 0 to 2 pi of e to the I x dx plus 17 divided by the summation from n equals 0 to infinity of 1 over 2 to the n plus 18 divided by pi to the power of 0. This equals 1. Ta-da, you did it. You're so smart. Go show your mom that problem. She'll be thrilled. Be like, Mom, it's 1. All right. But first, before you do that, you gotta be like, Mom, I bet you if I can solve this problem, you gotta buy me a new pair of Jordans. And then see if she does. That'd be cool. If any of you get new shoes out of it, let me know. That'd be tight. All right, there you go. There's your notes. You know everything about exponents now. Congratulations. Make sure you like and subscribe. Let me know if it sounds better. You don't have to like tell me on the video. You can just go to the WebEx and be like, yeah, Mr. Barnett, sounds great. Thanks. Until next time, have a good one, you guys. Stay out of trouble.